everybody, this is Coach Harris again with 5-minute tutorials. So I want to thank my cameraman Jonathan Jones today for helping me out. So we had a couple videos going on before. We're going to continue going with some integrated math 1 type videos. So today we're going to talk about domain, and then we're going to follow up with another video talking about range. But we're going to start today with talking about the domain from a set of data. So anyway, 2 concepts where we're talking about X values, Y values, things like that. Remember, we were talking about graphing. We dealt with having an X and a Y every time we had an ordered pair. Very simply put, when you have data or you have numerical information like that, you want to think the domain is the set of X values, okay? The set of X values in the data. All right, you can think of it as the set of inputs also, okay, depending upon how that it's put at you. If you want to consider maybe a graph, you could also think of the set of independent variables. So 3 or 4 different thoughts right there. Basically, it represents the same thing. So let's talk about it from a numerical standpoint. If I'm given these 3 points, 3, 4, the 0.56, and the point -3, 11, okay? When I'm talking about domain, I only want to look at the X values. So this is a Y value. That's not part of the domain. This is a Y value. That's not part of the domain. That's a Y value. That's not part of the domain. So if I said, what is the domain for these 3 points, I would write the domain as the set of -3, 3, and 5. Okay, now notice what I did right there. I listed them from smallest to largest. Okay, whether you're taking a college class, whether you're taking a high school class, you may want to talk to your teacher or professor, find out how they want that presented. I know for me, I like to have students go ahead and present it to me from smallest to largest. So that's the way I would write the domain like that. Now notice, there's only 3 members or 3 different pieces of that domain. What if we were thinking about something else? What if we had maybe something like a graph? Okay, let's take a look at a graph that's maybe continuous. On the coordinate plane, we got x-axis, y-axis, and let's say I have a linear graph like this that's never ending. Okay, it's a line, lines don't end. So these arrows reflect that. It tells me it keeps going here and here and here and all the way. All right, so now we're going to be talking about the domain of something like this. Okay, well, there's no ending over here. There's no ending over here. So what would we call that? Well, 2 different concepts could come in here together. So I could say it goes to -infinity over here and it goes to +infinity over here. How would we write that? Well, we could write that like this. I got -infinity, this is called interval notation, to +infinity. Okay? There is no ending for that line. Or we could also say, and that's the domain, we could say the domain is all real numbers. That symbol right there, kind of a double-staffed R, means all real numbers. Okay, so this represents all real numbers right there. Now, what if we were to take a look at it from maybe something that would be, oh gosh, probably a little bit more restrictive. Something like this. Let's say I have a graph that looks like this. And the domain for this graph goes from the X value of -3 to the X value of +3. All right, so what would the domain for this be? The domain here, or we see that it's from -3 to +3, but look at the difference between these 2 points. This is what's called an open point. The -3 is not included. Goes right up to it, but does not include it. This, I over-exaggerate, obviously it's a huge point. So anyway, that is circled in, it's colored in, that it is included, that point is included. A couple different ways that we can represent this same information. So I could say that the domain is all of the X values that are greater than -3. Not greater than or equal to, just greater than. And then all of the X values that are less than or equal to. Notice the difference. Open point, I have less than. or if it was the other direction, it would have been greater than, but we do not include the or equal to. Closed endpoint or colored endpoint, we have the or equal to. Now, what would this look like in interval notation? It would look like this. If I have no underline right there, I'm going to have a parentheses, -3. All right? This one has an or equal to, okay, so I'm going to have a bracket. So that would be a 3 right there. This means the same exact thing. So hopefully that helps you out as you think about how we represent domain, whether it's given a set of data or domain given a graph. Thank you.